Today we will be talking about variable stars. We are introducing the intrinsic group, which consists of the pulsating star class, more specifically RR Lyrae and Cepheids. What are variable stars? Variable stars are stars that change brightness, some ranging from 1/1000th of a magnitude to 20 magnitudes, depending on the type of star. These pulsating stars have luminosities that increase and decrease within a regular period, ranging from fractions of a second to a few years. There are different ways a star may change brightness. Pulsating variables shrink and expand due to internal forces. An eclipsing binary star will dim when it is eclipsed by a faint companion and then brighten when the star moves out of the way. Some stars are so close to each other that there is an exchange of mass as one star strips the atmosphere of the other.
What are pulsating stars? Pulsating stars are an intrinsic variable star that have a variation of brightness due to a physical change within the star. Their surface layers literally contract and expand periodically. The amount of time within that period further determines the amount of mass and the evolutionary stage that star is in. This knowledge of the time period is very important to astronomers because it tells them the period of pulsation and the star's light curve. This information dictates the interior process of the star and shows the period of pulsation and its luminosity, which in turn determines the star's distance.
RR Lyrae variables. These variables are named after the star RR Lyrae and the constellation of Lyra. These variable stars happen to be very important due to the fact that they are the brightest in their class. These stars are periodic variables that are commonly used as standard candles to measure galactic distances. They are usually found in globular clusters and all have the same exact luminosities, which makes it useful for finding distances. An average period is about 4 hours to 1 day. Average temperature, about 7,000 Kelvin. Average luminosity is about 80 solar luminosities of the sun. A standard candle, in astronomy, is a source that has a known luminosity. RR Lyrae variables have an average luminosity of about 80 solar luminosities of the sun. Astronomers can calculate the distance from its brightness and apply the information to measure distances that are too far away to use the parallax method.
Cepheid variables. Cepheid variable stars are named after the fourth brightest star in the Cepheids constellation, Delta Cephei. The Cepheid variable's period, how often it pulsates, is directly related to its brightness, or luminosity. These stars are also used as standard candles because they pulsate in a predictable way. The fluctuation periods can be large, like in Delta Cephei, or small, as in the case of Polaris, our northern star. Henrietta Leavitt is known for creating a period-luminosity relationship graph and reasoned that all stars in the cluster must be approximately the same distance from Earth. Now astronomers use her information to find vast distances by using 3 steps. The first, measure the period of the star. The second, use Leavitt's graph to determine how bright it really is. And the third, measure how bright it appears and determine its distance. Cepheids with long pulsation periods were intrinsically more luminous than their short period counterparts. This discovery was the basis of the Cepheid period luminosity relation, also called the PL relation, which remains an important tool for measuring the distance to nearby galaxies.
Knowing the period of the Cepheid, we can now determine its mean absolute magnitude, with the capital M, by interpolating on the period luminosity plot. The one shown below is based on Cepheids within the Milky Way. The vertical axis shows absolute magnitude, while the period is displayed as a log value on the horizontal axis. A period of 30 days is brighter than the sun by 10,000 times. as shown in the example. Once both apparent magnitude and absolute magnitude are known, we can simply substitute into the distance modulus formula and rework it to give a value for d, the distance to the Cepheid. The apparent magnitude in this example is 10.5. The absolute magnitude is 0.5. Watch as I rework this equation to find out d, the distance to the Cepheid.
A modern period luminosity diagram is actually a graph of absolute magnitude versus period of pulsation. In this diagram, we see that the longer period variable stars tend to be more luminous. Modern astronomers know that there are two types of Cepheids, something astronomers in the early 20th century could not recognize in their limited data. In this graph, I plotted the RR Lyrae variable star, the type 2 Cepheid variable stars, and also the type 1 Cepheid variable stars, also known as the classical Cepheid variables. In this graph, I also plotted the Cephei star. A graph of the brightness of the star Cephei versus time shows that it is varying in brightness with a period slightly more than 5 days.